Hey everyone. Um, Wanted to start up another Java tutorial video. What I want to show you guys today is if statements and while loops, and then get into the basic Karl statements as well, so you can start playing around with that. And I actually I'm going to do that in the reverse order. So I'm going to actually start with the Karl statements and then show if statements as they come up, while loops. Okay, so yesterday we went over creating variables of different types, the print statement, and then the for loop. And I asked you guys to play around with this a little bit, and if you were able to figure out how to print out the numbers like from 1 to 100 or in reverse order, good job. So if you wanted to do reverse order, all you would have to do is like switch the signs here. So start I at 10, I greater than or equal to 0, or I greater than 0, and then I minus minus. You could also do I minus equals 1 or I equals I minus 1, like we talked about up here. So, so I minus minus will now count downward. So it'll start at 10 and go down to 1, as you can see. Let's say I wanted to count by 2s, then I would have to do minus equals 2. And now it will just do the even numbers. So there's there's a few cool things we can do with this for loop. And we can even, put in other variables here that might get changed as your loop runs. So there's a lot of cool stuff that you can do with for loops. Okay, so let's get into today. I wanted to, again, discuss if statements and while loops. But before we do that, I'm gonna actually get into Karl and show you guys where we're gonna be writing some of our code and what all this means. When we had our package explorer on the side here, you'll notice that you have a bunch of different .java files. The ones we're really concerned with are the Karl file. You can feel free to look through some of the other ones. It has some kind of advanced code. If you want to try and figure out how this is working, feel free to look through those files. But otherwise, we're going to be working here. And this is really just the skeleton file. You'll see that it has some methods in here. It has some of the Java doc that we talked about. But sorry about that. It has some Java doc that we talked about yesterday. So here, this is just telling what the class file is. These are telling what the different methods do. And then we have single line comments as well as method headers, which we'll talk about. All right. So Karl extends robot. What this essentially means is that there's a robot class, which we can look at. And that robot class has a bunch of methods. Load method, move method, and you can kind of see here, if we actually have the outline open, this is one use. If the outline, you can actually see the names of all the methods and click on them. So this is all the stuff that a robot can do. Karl has a few methods, but none of them actually do anything yet. So what Karl can do is it can do anything that a robot can do because it extends robot, and we're going to basically add more features to this robot. So in our main where we said run Karl, essentially what we're doing is we're calling a couple methods. We're creating a string variable called map. We're loading that map, whatever that string variable is equal to. We're changing the animation speed, doing this thing called complete maze. So, um, what is complete maze? Well, that's a method actually that's written here. And this is going to navigate Karl through the maze to the light square. So when we run our code again here, we get this window here. And what we're going to try and do is get Karl to move all the way through the maze to the end square. And so we're going to write functionality that moves him and navigates him through the maze. Now, we write this code in this complete maze function here. So I'm going to write some code here. I have a method here called turn right, and it doesn't work. Because you'll notice that if I type Karl dot, this should bring up a list of all of my possible functions that I can do. One of which is turn right, but turn right as of right now doesn't actually do anything. I don't have any code in there. So at the moment, Karl can only turn left. That's the robot function. That one does work. So if I say turn left, and then I say follow that with a turn right, and then follow that with a turn left, and all I'm doing is I'm just hitting the enter key and it's auto-filling it for me. And then I run my code. You'll see that Karl turned left, then turned right, but he didn't actually turn back to the right and then turn left again. So now he's facing the opposite direction as to where he was facing before. Okay. So we need to fix this turn right, and this turn right function we can just write with 3 turn left functions, or we can use our new for loop. So get some practice with that. And so if you want to try and pause the video and write the for loop syntax that we talked about yesterday, see if you have that memorized yet. Maybe you have to look back, but it's good practice. So I'll give you a couple seconds to do that. All right, and then so the syntax is int I equals 0, and again, it doesn't have to be I; it can be any variable. In this case, I less than 3, because we want this to execute 3 times, I plus plus, and then we have brackets, and then Karl turn left. And so turning right is turning left 3 times. Now, one thing in Java is these squiggly brackets, you have to make sure you're putting these in and that you have one at the beginning and end of every for loop and every method that we have here. Now for this for loop, we don't actually need these ones. When you have exactly one line of code with just like one semicolon, and that's all you're executing in the for loop, then you don't need the curly brackets. But you have to be careful about this. Like even if you indent this, so let's say you indent a print line that says hi, you might think, oh, hi is inside the for loop. It's gonna print hi 3 times, but in fact, it only prints it 1 time. And this is because we don't have the curly brackets. If I wanted to print it 3 times, then I would have to put the curly brackets grouping around those. So it will only loop the first line of code if you don't have the brackets. So in this case, for this method, we don't really need that. So without the squiggly brackets, the for loop will only loop 1 line of code. So sometimes it's, it's just 1 line of code that we need to loop, and it's very quick and easy to just write it like that. So, okay. So now let's see what else we can do with Karl. I obviously he's already facing the right direction when we start our maze, and so we don't need to move him at all. When we start our maze, he's got to move 1, 2, 3, 4, 5 squares forward. And so, we could write a for loop to make him move forward 5 times. For I equals 0, I less than 5, I plus plus, Karl dot move. And dot move will make him move 1 square in the direction that he's going. So now when I run this, he moves here. Okay, now I need to turn right and move. So after this, I'm going to write my code in sequential order. I'm going to turn right, and then I'm going to move again. And test my code again. I'm going to actually modify the delay a little bit, make it like 0.2 so it goes a little bit faster. All right. Now I need to turn left and a move twice. Now in this case, yeah, I could do a for loop that executes twice, or I could just do a move, like type it twice. I would say generally, once you repeat a line of code 3 times, then you should probably use a for loop. But twice, it's like maybe you could use a for loop, but probably fine to not. Okay. So you can take some time and navigate him through the rest of the maze here and see if you can get to this light square. Later on, a fun challenge might be to try to get him to navigate through a maze, any maze, just trying to get him to find the light square. And I have a method for that down here, complete any maze, but this is a challenge. I'm not going to assign this, but if you are feeling up for it later on, once I teach you guys if statements and while loops, then that might be something we can do. Okay, so there we go. So Karl can move, turn right, turn left. Now there's a few other things that Karl can do. We're going to go ahead and switch the map that we're in. So if I go to my package explorer here, you can see all of these are different maps that Karl can load in. And right now we're using the maze.txt, and if I click on that, you can see actually what it looks like, and you can see that that's actually very similar, in fact, to this. It's all the X's represent these red brick squares. The colons represent the dark square. The W represents Karl's starting position and which direction he's facing. So there's W, S, E, and N for west, north, south, and east. And then a period instead of a colon is a light space. So you can actually make your own maps. Like we can actually add in a row if we wanted to. You just have to make sure it always lines up and has the same number of rows and number of like columns per row. So if you add a row, you have to make sure it lines up, otherwise the file won't work. But you can see actually I shifted it down. I've added a row, and now there's a row of bricks here, and I could do the same thing down here, and now I've added like a little border around my maze. So you can actually play with these maps and design your own, and they're pretty easy to make. All right, so we're going to look at one called stairs, which is this one here. And it's a pretty simple one. So I'm going to go ahead and take out this line of code that says complete maze. And I'm going to load in stairs.txt. And I'm just going to run this code and see what happens. Okay, so the idea behind this one is Karl has to move up these stairs and he has to clean them off. They're dirty, and he needs to make them match the background here. So there's light squares and there's dark squares. So he's going to turn all the dark squares into light squares. So how can we do that? All right, so the first thing we're going to do is we're going to create a method, just kind of like we have here for complete maze. We're going to add a method. Right? We're going to be doing these ones later on. So I have a couple method stubs in there for you. But this one is going to be called, so we're going to start all these methods with public static void. We won't get into what these keywords mean right now, just that you need them. Public static void sweep stairs. All right, and the Java doc for this would be Karl will sweep the dust off all the stairs. Okay, so using what we have right now, you might look at this and say, okay, got a lot of windows open right now. All these. All right, so you might look at this now and say, okay, I need to go up each stair, and I need to do this 3 times. 1, 2, 3, and I get to the top. So I'm gonna repeat on a for loop 3 times a move, turn right, move, turn left. So I got my for loop 3 times, and I'm gonna repeat the code. Now you can continue to type Karl.move if you want, but you can also just type move or this.move. Actually, sorry, you can't do this.move. My apologies. You could, but you can just do move, and that will work. So feel free to do that. So move, turn right, move, turn left. And this works really nicely. We write this code. Oops, we need to call this function. So in main, I need to actually call sweep stairs. And this works nicely as to moving up the stairs. Now, it doesn't actually make the squares light yet. We haven't done that yet. But once I get to the top, which is here, I'm going to go ahead and say, Karl, make light. So there's 2 things. There's make light and make dark. All right, make dark obviously makes the square dark. Make light obviously makes the square light. So in this case, we want to make the stairs light. So we'll go through like that. And that looks pretty nice. All right, so now what happens if, let's say one of the stairs was already clean and the robot didn't need to actually clean it. So if I go to my file here, and maybe I change one of the colons to a period and save that file, and then run my code again, you'll see that this square is light already. And Karl actually has an error here. If he tries to make a square light that is already light, then you get an exception, you get an error. And I can see where that's happening in sweep stairs Karl Java 49. And this is because I changed this period to a colon. But our code, we should try and write in a way that it won't break whenever we have something like this happen. All right, and this is where a conditional comes in, an if statement. We studied this in Java. We want the computer to make a decision. And namely, we want the computer to check, is the square that I'm currently on dark? If it is, I'll make it light. And if it's not, I won't do anything. All right, and now the syntax for an if statement is very, very similar to that of a for loop. So we have if, and then in here, parentheses. And then here we're going to put in a conditional, something to check, something that's going to return a Boolean, a true or false value. Now, we are not comparing numbers or anything like that. What we're going to be doing is we're going to be actually calling a function, or in Java they're called methods, a method that returns a Boolean value. And in this case, there's 2 Boolean robot functions that will be useful. One is called front is clear. And this will check to see if the square in front of the robot is available to move to. In other words, it's a valid square to move. So if the front is clear, that just means the robot can move there. It doesn't necessarily mean that the square is light or dark. And all it means is that there's a square there that exists that's not neither a wall nor off the board. On dark is another one, and this basically just says, is Karl on a dark square? So if it's on a dark square, it returns true. And so we can say that. So if Karl is on a dark square, make it light. And now the same thing goes with if statements. So if statements need these curly brackets. And so now the curly brackets kind of get a little messed up if you just have to make sure that you have a curly bracket for the for loop as well as a curly bracket for the if statement. Now, if you're just doing one line of code like we talked about before, you don't actually need these curly brackets on this if statement. I would encourage you guys to use curly brackets initially as you get used to them. Then as you get more used to the syntax, go ahead and take them away. But you know, anytime you're just using one line of code, you don't actually need them. So if Karl is on a dark square, he'll make that dark square light. If I run the code now, you'll see he actually will be able to skip over the square now without crashing, and he'll be able to complete the map. Okay. So we've made one modification to the map. Now, what happens if I make another modification to the map, which is this? I add in another row of squares at the top and add a column, add a column of x's at the end. Now, my stairs file looks like this. This is still the same pattern, but it doesn't work now because my for loop only repeats this code 3 times, and I need to repeat it 4 times. So how do we fix this? Well, if you think back to what we did in Java, whenever we had something that we wanted to repeat a number of times, we used the for loop. If we had something that we wanted to repeat, but we didn't know how many times we wanted to repeat it, we used a while loop. Okay, and so we're going to actually introduce that while loop in now. So what I'm going to do is I'm going to go ahead and delete this code that's my for loop. My for loop no longer works for this problem. Yeah, we could make it work. There's ways, but the while loop makes a lot more sense for this. Okay, so what is my condition for ending? Looking at one of these maps, what's my condition for ending? Well, my condition for ending is that Karl is facing upward and can no longer move. The front is no longer clear. So basically what we're going to say is we're going to say while the front is clear. And so what this will do is it'll check this map and it'll say, is the front clear? It is. Okay, I'm going to move, turn right, move, turn left, and I'm going to create this square and make it light. Now he's facing upward and he asks the question again, is the front clear? Is this space a good one to go to? And he's going to continue that process all the way up the stairs until he gets to this last square. And after he makes it light, he's going to ask the question, is this front clear? And because it moves off the grid here, then he'll say, no, it's not clear. And that means this while loop will end and the method will then end. Okay. Now there's a couple things that we can add to this while statement when we're checking. In Alice, they always made you do like equals equals something equals true. You don't necessarily need that. This is essentially the same thing as just saying while front is clear. So while front is clear, that's the same as saying while front is clear equals true. If it makes you feel like more comfortable with the syntax or makes you understand it a little bit better as to what's happening, then you can certainly add these in. What if I wanted to, what if I wanted to do a while loop while the front is not clear? Then I could say equals false. Or what if I wanted to make all the light squares dark? Then I could say if Karl is on dark equals false. Then Karl make dark. Right? That's like a darken instead of a lighten. But another way you could do this is just by negating this statement with an exclamation point, and this is a lot shorter to write. And essentially this just means while not on dark. Okay, so exclamation point before a conditional negates it. So, you might find a use for that in some of these projects. All right, so I'm going to wrap up this lesson here. We showed you quite a few things today. Showed you just some basic syntax. We actually wrote a method for turn right using our for loops. I showed you guys turn left, move, make dark, make light, on dark, front is clear. So all the robot methods that are available in that library. We also talked about if statements and while loops and conditional functions that we would put in there. So there's a lot to learn here. I'm going to do basically one more video of some notes and introducing the projects to you guys. And then basically you're going to just be spending the next few weeks learning this syntax and completing some of these like mini projects, kind of like little puzzles like we did today with the stairs. So I'm going to sign off for now, but thanks for watching.